2, 3. PFRQ number 3. All right, here we go. So, first question says, first part of question, PFRQ 3, says list all possible rational zeros. In order to list all possible rational zeros, you must find all the factors of the constant and the leading coefficient. Here's your constant. Leading coefficient is uno. We love that. So P over Q looks like so. The P is the factors, are the factors of the constant. So we got plus or minus 1, plus or minus 10. Those are the most obvious. Then we have plus or minus 2, and then plus or minus 5. Anything else multiply, give me 10? Nah. And then we have plus or minus 1. That's our leading coefficient. So listing all possible rational zeros, that's not sufficient. You got to divide it out. So we got positive 1, negative 1. We have positive 10, negative 10. Positive 5, negative 5, and then positive and negative 2. I'm okay if you use positive or negative on that. The answer to this one is that. Okay, next. It says use the Descartes rule of signs to determine the possible number of positives and negative zeros. So let's go possible positive. Possible positive, we just count the changes in the sign as it is. Okay, so we got, I'm going to write extra stuff so that I can be visual so you guys can see what I'm talking about. So I'm just going to rewrite what we got right here so far. Plus 17x minus 10. So we have a change there. So I'm going to put a yes, no, not a change there. Yes, change right there. Yes, change right there. And that's it. How many yeses we have? We have 3. So there's 3 possible. 3 or how many? 3 or 1. We have to drop 2. 3 or 1 possible positive zeros. And then we got our negative zeros. We got to do something with the negatives. So to do the negatives, what you do is you plug a negative x inside of your function, and you write out what you get. Now, pretty much when you have an even power, the negative is going to go away, because whenever you have an even number of negatives multiplying to each other, you're gonna get a positive result. So we have positive x to the 4th. And then the next one, the sign's going to change because we have an odd exponent. So we have plus 5x to the 3rd. The next one, the sign is going to change because... Oh, wait, I'm sorry. The sign's going to stay the same because we have an even. So we have minus 3x squared. And then when I plug in negative x to the 17x, I get negative 17x. And then the negative 10 stays negative 10. So here we have a no change. Here we do have a change. Here we have no change. And here we have no change. So we have one possible negative. I'm going to say 1. Let's just spell it out this time. 1 possible negative 0. All right, so that part's done. Got my 2 answers. We're good. Now the next one says use synthetic division to test the possible rational zeros and find the actual zeros of the function. Okay, here we go. Okay, so I mean you could pick whatever you want to start trying. Let's see, we have a lot of possible positives. So we have a possible of 3 positives, but then again it could also be 1. But I think I have a better chance of testing all the positives, so that's what I'm going to do first. Can you guys read off for me what the coefficients are, because I can't see it right now? Okay, are there any missing terms in this? Like, this is x squared, x to the 3rd, x to the 4th? We're good? Okay. All right, so you drop the first number, so you have 1. And then you go 1 times 1 to get the next number. Then I get a negative 4 times 1 to get the next number, negative 4. And I add that, I get negative 7. Negative 7 times 1 is negative 7. Negative 7 plus that is 10. 10 times 1 is positive 10. Hey, I got lucky. The first one I chose was a 0. I don't have to try it again. Yay. Now, what does it say? Use synthetic division to test the possible rational zeros and find the actual zeros of the function. All right, so far we have 1. 1. Okay, do we have more? I don't know. Let's see if we can factor that right there. We have 10, negative 7x. What's the next number? Negative 4. So we have negative 4x squared. And then we have 1x to the 3rd. All right, is this factorable? Let's see. If I group the first two, group the second two, I could take an x squared out of the first one, then I get x minus 4. Can I take something out of this to make it x minus 4? No, sad time. So we need to find another 0. Boo, everybody cries. All right, so then we have 1, -4, -7, and 10. I got those from what I was left over with. Can you start from the beginning again and do all these numbers? Yes, but why? Okay, I'm going to try 2. I tried +1. I'm going to try +2 this time. So let's try that guy and see if we can find another 0 here. I bring down the 1. 1 times 2 is... 1 times 2 is 2, and then we get -2. -2 times +2 is going to be -4. -4 times, plus -7 is going to be -11. -11 plus times 2. Man, all my words are junky right now. And I get -12. That one doesn't work. Boo. Okay, let's do it again with, what do you guys want to try? +5 or +10?
10.
Try 10? All right, let's try 10. We have 1, -4, -7, and 10. All right. Okay, so I bring down the first number. That's going to be 1. 1 times 10 is 10. Then we get a 6. 6 times 10 is 60. Uh-oh, I don't think that's going to happen. And then we get a 53, and so it's 530. Oh, okay, so let's try our last positive option, which is a 5. You jerks, you made me do extra work. You knew it, huh? All right, let's see if this one actually works. Man.
But this won't work.
It doesn't work? Let's see. I bring it down to get 5. 5 times 5 is 25. 5 plus that is going to be 21. 21 times 5 is going to be 105. Uh-oh. That one doesn't work either.
Because it said...
Oh, so you're saying I was stupid to try it because...
Yeah, there's no point testing it.
Okay, but what if there was 2 1s or 3 1s that are zeros? Oh, what a doofus. I did a synthetic division wrong. Okay, then we get 1. 1 times that is that. Then we get -2. Oh, there we go. All right. So you guys are confused, right? Why are you confused? Because now we found that 5 is a 0, and you're like, but there's no other positives to try. But what if there was another 5? Right? Then there would be 3 positive zeros. Right? Right. So let's write out what we have left over. We have 1x, and then this is going to be x squared. So we have this nasty looking thing. Can we factor that? What times what gives me -2, and then adds to give me +1. Let's see. -2 add to give you +1. +2 and -1.
Yep.
So this is x plus 2, and then x minus 1. Oh, snap. So 1 has a multiplicity of 2, right? Because the final result is going to be x plus 2, x minus 1, and x minus 1, and x minus 5. Right? Okay, because for this, I factored, and I got that. Okay, so I got that when I factored it more, right? And so what did we take out of our polynomial to get to this spot right here? What did we take out? We took out a 5, which is your x minus 5. And we also took out a 1, which is your x minus 1. So there's 2 x minus 1s. So there are 3 possible positive zeros, but one of them is repeated. So it looks like there's 2. Does that make sense? Okay, let's see what else we got here. It says list the completely factored form of... Oh, I did that right there. Let me move it over. I should have just read it before I started going off. Okay, all right, Shang. All right, last one says, using parts A through D, graph the function. All right, let's see what we got here. So the first thing you want to think about are your x-intercepts. We found -5, right? Let's see, 1, 2, 3, 4, 5. So, -1, 2, 3, 4, 5. So we have a point right here at -5. We also have one at -1. Is it plus? Oh, dang it, you're right. What a doofus. Okay, so at 1 we have an x-intercept, and at 5 we have an x-intercept. Okay, do we have any other x-intercepts? We got a 2? Is it -2 or +2? -2? Negative?
Yeah.
Are you guys sure? I can't see my work because I had to delete it so I can get down there. Okay, so there you go. All right. And there's a multiplicity of 2 on the 1, right? So I got to make sure I bounce on that one. I'm just going to put a B there, so I'll make sure I bounce. All right, now we need to think about our end behavior. But before we look at our end behavior, let me correct something here. We didn't put a -2 right here. Thanks, you jerk. Right here. Right? We found it when we factored this. There's 3 zeros. Well, actually, there's 4 zeros because one was repeated, right? Right. Now let's talk about our end behavior. So for end behavior, what you need to know is, what was it? Oh, yes, degree. Is my degree even or odd? Even. That means we're going to go up, up, or down, down. The deciding factor in that is the leading coefficient. The leading coefficient is +1. So are we going up, up, or are we going down, down? We're going up, up. So when we come back to our graph, I'm going to put little corners right there just so I know where I'm supposed to be ending on both sides of my graph. So I got to approach this -2 because when you graph, you always start from the left side of the graph. And because we know the end behavior is up there, we're going to start up here and we're going to go at the -2. So here we go. And I'm supposed to go through or bounce off the -2. Okay, so I'm going to go through this -2 and then I'm going to go bounce off this +1 and then I'm going to go through this 5. Okay. Oh, wait a second. The y value, the y-intercept is so easy to find. Can you guys plug a 0 into it and tell me what it is? What is the y-intercept? -10? Oh, snap. Where's -10 at? Let's count by -2s. That sounds good. -4, -6, -8, -10. So we're supposed to be going through that point. All right, let's do that. There we go. All right, done. If you were confused about finding the y-intercept, whenever you find a y-intercept, you just need to plug in the 0 for the x. Because think about that. On any graph, if you're on the y-axis, what does the x equal? Equals 0, right here. It equals 0, so you plug in 0. And look at the beautiful part about plugging in 0 to the function. What happens to all the numbers?
They all go by.
Yes. Shh. This is why it's like it's no contest. You better plug in the freaking 0 to know that your y-intercept is -10. That's too easy. It's too easy to find the y-intercept, so you should.